to get a 4.0 to pass or whatever it might be. So it's a little bit complicated, but this is what you do. You take your score that you have got, your grade, what you call it that. And I'm talking about the percentage grade. So let's suppose that your grade is 91%. And from that number, you can calculate eventually what you need to get a 2.0, a 3.0, or a 4.0. So you take that number, 91, and you multiply it by 7, or whatever your number might be. So I'm going 91, I'm timesing it by 7. Try that again. There we go. And what you've got there is essentially how many points out of 700 that you've got. So there's your raw score. So basically, if you didn't get anything in the final, that's what your score would be out of 1,000. So you want 750 points to get a 2.0. You want 850 points if your goal is a 3.0, and you want 950 points if your goal is a 4.0. So what you basically do is a little subtraction. My raw score is 637. I need 750. If I take that guy away from that, it leaves me with 113 points out in the final. And the final will be worth 300 points. So you can imagine if that was you, you would need to get 113 in the final. Now, if you wanted to pass, if you wanted a 3.0, if that was your target, then you would do the same kind of subtraction, but you would need 213 points. And if you wanted to get a 950, you would need to get 313 points, which is clearly impossible. So that person can't get a 4.0 no matter what they do. Every 10 points, increases your grade by 0.1. So, for example, if you got 213, you would be a 3.0. If you get 223, you would be a 3.1. 253, you would be a 3.4. Do you see how it works? So you take your score, your 91, multiply it by 7 to get your raw score. And then all you need to do is figure out how many points to get 750, that's your pass. How many more points to get 850, that's your 3.0. And how many points to get 950, and that is your 4.0. Are we comfortable with that? You think you can figure out what you need now? There is virtually nothing else to go. You've got 1 week's attendance. Today's Friday, so that's over with. But that typically will make no real difference. There is, of course, 300 points up to grab in that final. And I'd be amiss if I didn't tell you that people tend to not do well in finals compared to what they do in tests. And so you have to be really, really prepared. And otherwise you could easily get a shock. And you think, well, I'm getting 80s in my test, so I'll probably get 80s in my final. It doesn't work that way. Your tests are over 3 weeks, not over 10, 11 weeks. Your test has got 3 times as much content, right? That's 3 times as many things for you not to remember. I mean, all of these things add up. Any questions so far?
Is the final online or on paper?
The final will be as a PDF, and that PDF you will do just like you did your normal test. All right, so it won't be in WebAssign. It will be in a PDF that will open up, and you will write all your answers down on paper and upload it into Canvas in the usual way. There'll be a Zoom during that entire period in the usual way. Pretty much it will look like a very big test.
Okay,
You
so you want us to show our work and all that.
Yeah, with one kind of change in plan. So let me show you what that change in plan is. I'm going to nip over now to hopefully our class, but if it's not, it's fine. It's very similar. Let me check. It is our class. Good. Right. So I'm going to go to syllabus. And if you go down here, can you see that our final exam is going to be on Thursday the 9th, which better match that guy. There it is. So on Thursday the 9th from 10 till 1. Just a little bit weird, but that's what it's going to be. Now, if this time doesn't fit, because I don't know, maybe you're doing Greek or some weird class that nobody knows about that's duplicating, and we can arrange for you to take it at an earlier day and do the test then.
The
Yes.
syllabus for me says Wednesday.
It does. Am I in the right one? Let me check. After saying that, I could easily be in the wrong one. Just to show you what my life is like right now. These are all my classes either under construction or that I'm looking at for other people. And this is our class. So I may well have clicked in the wrong one. Let's just check. I'm on syllabus. It says Wednesday and it's 70:10. You're right. That other one I gave you was my other class. So it is Wednesday, so I'm glad somebody's paying attention. And it's from 7:10, which again is a kind of unusual time, but a different unusual time. So if you can't do it in Wednesday, I have a Thursday slot because the other class is doing their version of this. Okay.
How many problems will there be?
Right, let's start with that one. If I, damn it, there's so many pages on this thing. There we go. I have somewhere, evidently I don't. So where did I put it? Oh, okay. I have a thing called Practice Final and Solutions. You see this guy here? Right. Now, the reason I'm clicking on that is that it's like the final, it's just a big version of it, and it'll allow us to get a kind of look at how your final is going to exist. And I can tell you how many questions in your final in a few minutes. There we go. I should be able to do it like that. That's fair. Right. It'll look just like this guy. Obviously, it won't have the solutions in it, and it will consist of 10 multiple choice questions. So 10, 10 multiple choice. Each multiple choice question is worth 10 points, so that's 100 points. And it's basically from week 1 to week 11. So can you recognize, well, in this case, it stops at integration. This particular practice final, and I'm going to see if I can find an older one that covers more stuff, doesn't do chapter 9. And that doesn't mean chapter 9's not in the final. It's just I never get around to doing it probably when I was making it the last time. But they're going to be 10 multiple choice questions, 10 points each. And then section 2. Oh, rewind. In the multiple choice questions, all I will see from you is that question 19 is B. I will not be looking for working in section 1. So if all else fails, you can at least guess, right? Because all I will see is number 1 is A, number 2 is C, number 3 is D, and so on. Then we move on to section 2, where there will also be 10 questions. And section 2, typically each question is worth on average 20 points. So that's the other 200. So 100 from section 1 and 200 points from section 2. And in section 2, you show me the work. Now, in this one, I've made gaps so that if you printed it out, you could actually write your answers next to the question. But on the day of the final, I'll probably get rid of all those gaps. It'll still be your questions. And for instance, can you see this one here finishes on hydrostatic? Right. So you know that there's no chapter 9 in it, but that doesn't mean there won't be, because I can guarantee you right now, there will be questions from chapter 9 in the final. There will be. Right, and here's my solutions. No guarantee that they're all correct, but at least a lot of them will be. So you can, there's that hydrostatic one to finish with. So I think the question is, how many in the final? 10 multiple choice worth 100, 10 section 2s worth 200. The multiple choice questions, I do not want to see the answer, just A, B, C. And in section 2, I need to see the answer, because if I don't see the working, then you've just went in and cheated by looking up one of the various many sites that you can plug things in and get the answers to them. So no working, no points. Are we good?
I have one question, and
Sure.
I missed that, but is section 9, I mean chapter 9, included in the final?
Yes, it is. Even although it's not in my practice final, it is guaranteed to get questions from chapter 9, the differential equation stuff. It will happen.
I see.
Okay. Now you have 3 hours to do the final, which might seem like a lot of time. It's not. It'll zoom by. So you've got to make sure that you've got any notes, that you've got anything that's physically paper written down or of that type. You want to make sure that you've got them organized well, and that actually you don't need to look them up, because if you have to look up everything, you'll run out of time. So you got to have a big chunk of that stuff inside your head. Now let's show you if I can find the next bit. Right, slightly out of sync, but it's in front of me. There's a thing called 152 class resources. What you've got here are other things to help you. For instance, if I click on chapter 7 and I pick trig substitution, I have some other videos that you can watch. So if you find that trig substitution is not your thing, here are some YouTube videos. If I click on this one, no idea what that's going to look like, but here we go. There you go. And you can watch it. And, there's an example of the integral. You recognize that little right angle triangle that we used? I think it's helpful if you see other people's ways of doing things, because just because I do it the way I think makes sense doesn't necessarily make sense for everyone. If you click on this one, what I essentially have is some help with various things. Here we have some PowerPoint. So if you want to go over a PowerPoint on a section, and this one is self-contained. Although it says 7, it's actually chapter 6. And so there's another resource for you. Math 152 class resources. On the day of the final, that will disappear. In fact, the only thing that will exist on the day of the final will be one module which will be called final exam. And in that final exam, you will just get the final exam and a link to the Zoom meeting and a link to upload your work. everything else will be gone. That includes everything on WebAssign will have disappeared. So anything that you want to use, you're going to have to be the person who supplies it. You know what you find useful, you know what you already know and don't need to print that. Are we good? And let me go back to syllabus and tell you what the content of your final will look like. I do finals in chronological order, which means essentially that the first question that you will see will be calculating the areas under curves. And the last question that you will see will be solving linear differential equations. So as you go through the test, it's like week 1 is the beginning, and then week 2 questions, then week 9 questions, and then finally, right at the end, differential equations, week 10, 11 questions. I like to do tests in that order. So you should be able to figure out very roughly by the position of the question when you did it, right? So if it's in the middle, it's probably something you did in week 5, for example. But any questions about that information?
I had a question. Are we going to have questions on at the very, very beginning, like where we had the graphs with all the rectangles?
Yes, I'll phrase it that way. I may give you a question using Simpson's trapezoid, midpoint, left or right. Yes, that may happen. And will it happen? No guarantees. Half the things that you study for will not appear in the final, because if I put a question on every single thing that we've done, it wouldn't be 10 and 10 anymore, right? It'd be 20 and 20, and that's far too much for 3 hours. Of course, Murphy's Law says, if you only study for half your stuff, won't that be the half that's not in the final? So you got to assume that anything and everything could be in the final, and that way you won't be surprised. You'll be ready.
So it's very possible that the real test is very different from the practice one.
Well, not 100% different. I mean, there's only so many ways you can ask someone to do the area between 2 curves. So if I choose to do that question, it will look just like the practice final, right? It'll be here's F, here's G, find the area between them. So no, I wouldn't say that, but there are going to be things in the final that's not in the practice, but there are also going to be things like in the practice that will be in the final. Off the top of my head, let's suppose I decide to do a variable separable differential equation, right? That is not in this practice final, right? But it is in the final example, right? I mean, I've mentioned that as an example. But suppose I do the volume of revolution where you rotate a shape around the vertical line x equals 1. I may not have that particular question in the final, the practice final, even although it would be in the real final. So I'm not sure if I've answered that question or made it muddier. If you look at the topics, let's randomly pick one. Average value of function. You might or might not get that question. Right? 50-50 chance it'll turn up. Integration by parts. You might or might not get that question. There's a 50-50 chance that that'll be in. So you have to be making sure that you know how to do both those questions, because there's a pretty good chance that at least one of them will be in the final.
Yeah, that makes sense.
Okay, so don't treat the final, just adding to what I've said, don't treat that practice final as, oh, well, he's just told us what the questions are going to be. He's just going to change the numbers. You'll be disappointed if you think that's going to happen, because it ain't, right? You will get questions similar, but not the same, because that's how math works. Right, I have some chat questions, so there may be some people who are asking questions that way. Eric, 20 questions in total, yes. Margaret, will we receive partial credit? You will for section 2. So if you only know how to do half of a question, do the half that you know and then stop with it. You can't think of what to do next. If you do half a question and it's right, you'll get 10 points. If you do a question and it's wrong, you'll still get partial credit, and it depends on what kind of wrong you did. If the wrong is simply arithmetic, 3 times 2 is 5, or you lost a plus or a minus, you won't lose much out of that. If the mistake is you did a totally weird, non-correct method, then you will lose a lot of points because you're not doing it. So I tend to look at, are you doing the right process? And then if you make a mistake, I'm more generous.
So
yeah.
out of curiosity, I have different processes for some of the problems, like the hydrostatic force.
Don't care. If it's
Okay.
mathematically correct, I'm cool with it. For
Cool.
instance, some of you do integration by parts using the UDV method. Totally okay with that, right? I can't think of any off the top of my head, but there probably is. I can tell whether it's good math, whether it's a math I teach doesn't matter to me. Yes, of course, if you get partial credit, any point improves your grade. This is someone's question. You know, so if whatever it is, think of points make prizes, right? You already know how many points you need. Every single point you get is going to lead to that. Multiple choice, little warning here. Multiple choice are deceptively difficult. Not because the math is difficult, but a good multiple choice has, say, 4 answers, one of which is correct. But see the 3 wrong answers? They are very sensible wrong answers. So if you're a little careless or a little quick, you will get an answer and it will be one of the 3 wrong answers. And you will think, yay, 42, I got 42, I must have got it right. Doesn't always mean that. What it could mean is, oh, he's figured out one of the common mistakes people do in that question. And when they do that common mistake, the number 42 is your answer. So you have to be careful with multiple choice because it's either all in, right? You get all the points or you get none. When you're doing multiple choice, if it's taking you longer than 5 minutes to do it, you're doing it wrong. Just pick C and move on because the multiple choice should be cheap and cheerful, right? They should be 5 minutes or less. You might be able to easily find some shortcuts to it, you know, and get the answer very, very quickly, right? If you think, oh God, I'm going to have to do an X sub, and then after that X sub, an integration by parts, and then I'll get the answer. If that's a multiple choice question, that ain't the way to do it. You're doing it wrong. Right, any more questions? I don't know if that's good news or bad news. Right, has it? Yes.
I have a question.
Yes.
So you said that the test is going to be in chronological order.
Yes.
Does that apply to both parts of
Yes,
A?
it does. So multiple choice is chronological and section 2 is chronological.
Okay, thank you.
Got more questions? Right, next week is our finals week. So as far as I know, I'll double check that. Monday is not a normal, oh, Monday is. I take it back. Right. You might not know what you don't know until after the weekend when you've started revising, right? Monday is going to be an open day. And all I mean by that is you just turn up and say, hey, I need help with X subs. Could you show me again how to go through it? Yeah, that's it. I'm fine and I'm off. So you're going to get your attendance for Monday, whether you turn up or not. You only need to turn up for whatever. It's a bit like an officer, right? Just turn up, do what you want to do, and then leave. So I'm going to have that day since it is a review day. And it's down here as a review day. That's what I'll use it for. Anybody got a question right now? Any topic that you want us to get started? We can do something for 10 minutes or so.
I do.
Yeah, what you got, David?
Question 7 on homework, on the most recent homework.
Okay, what's the question? Do you have the number?
It was question 7 on on section 9.5.
Okay, 9.5. Do you know what that one is? Otherwise, I could look it up, I guess. It'll be a differential equation because they all are. It'll be a linear differential equation as well. I guess I could find out, but it's quicker if you've got it. If you don't, then I'll look it up.
Yeah, I have it. It's dy over dx plus 2xy equals x to the power of 3 times e to the x squared.
Okay, so it is linear, as we know. You won't know in the final that this is a linear equation because all you'll be told is solve the differential equation. But I hope you recognize this as a linear and not a variable separable, right? They kind of look different, don't they? This is linear. Now, in this case, stage 1 is kind of done, so I'm not worried about that. I identify the P of X, which is him, and the Q of X, which is him. And then I'll go and I'll do the integration factor, which is e to the integral of P of X dx. Actually, this is kind of how I would like you to do your working. I mean, not everyone does it that way, I understand that, but can you see that if you look at what I'm doing, you can tell where I'm getting the P and where I'm getting the Q and what numbers I'm doing with what things. So if I screw up somewhere and make a mistake, at least I'll be able to see if I'm doing the process right or if you're doing it correct. So in this case, it's the integral of 2x dx, which I believe ends up being that guy. So far, so good. Now, y, the solution, is 1 over I of x, the integral of, I should put it in full, I of x, q of x, dx, plus c. For instance, wouldn't this formula be a very useful formula that you have as your notes so that when you want to go look, right, you got this guy, because I'd prefer you to memorize it, but you know, maybe you're not there yet. But certainly that would be something I would be doing. So it'd be 1 over e to the x squared, the integral of e to the x squared times x cubed e to the x squared dx plus c. And you might have been hoping for this to cancel that, but that's not the way it worked out. In fact, when you multiply this and this together, you do not get ex to the 4. You probably were hoping it would be ex to the 4 because then you could do a u sub. What you in fact get is that when you multiply two things together, don't you add their powers? So you see how that's e to the 2x squared. Now I'm going to do this guy at the side. We need to do that guy. I guess the problem is, what method are you going to use? There are really only 2 viable methods in almost every one of these questions. Isn't it a u sub or an integration by parts? Would you agree? It's a U sub or an integration by parts. And does anybody know which one is the only one of those two that's actually going to work?
By parts.
If you go through it, and I'm not because I don't have time, you'll find out that the minus integral that you get, remember that take away the integral of f capital G, f dash capital G, ends up being just as ugly as the original.
U sub.
So we're going to have to go U sub. And what kind of U sub could we do here?
X
Squared. Yes, is the answer. X
Alright.
squared is right. So we'll differentiate with respect to x, and we get that. We do the crossover, and we get that. And we divide both sides by 2x to isolate the dx. And so I have an x cubed. 2x squared becomes 2u. And the dx becomes 1 over 2x du. And these cancel, but only partially. And now I have 1/2 x squared e to the 2u du. And you might think, oh dear, I've got an orphan x squared left over. That normally means I've screwed up, but it doesn't mean you've screwed up this time. What can you replace the x squared with in terms of u?
U.
U.
So what you've now got is 1/2 u e to the 2u du. Do you recognize that this integral is doable? But what technique will I use to integrate this one?
By parts.
Now I'm going to do by parts, and I'm going to make this the f and this the g. So it's going to be f of u, capital G of u, take away the integral of f dash g, capital G of u, du. And so we have 1/2 u. If you integrate e to the 2u, you get e to the 2u. What else do you get when you integrate e to the 2u? Integrate e to the that's what you would get if you differentiated. So what will you
Oh.
get if
1/2.
1/2? You had the wrong hat on. Take away the derivative is 1/2, and the integral is 1/2 e to the 2u. And this line is just to make things look pretty. This guy's good. Integrate this guy, you get an extra 1/2, so you end up with that fella. Return the u's to x's. And now we have this guy. So it's 1 over e to the x squared, 1/4 x squared e to 2x squared. Take away 1/8 e to the 2x squared plus c. I'd probably let that one slide, but if you wanted to, you could distribute this. It wouldn't be much better looking, so I'm not bothered if you don't do it. Did you see that that question had both techniques in it? You needed to do a U sub, and then after that, you had to do an integration by parts. That's pretty rare. Isn't it almost always just one one of those two techniques will solve the problem. But you know, you have to be flexible. You know, you get what you get.
Let's say instead of the first term being x to the third power, it was something like x to the fourth power.
X to the fourth power, which would be, let's see. So this one here was maybe x to the fourth,
Yeah,
something like that.
yeah.
The question would be impossible. Whatever technique I used, I'd end up with an orphan x, or later on I would end up with a u to the 3/2 e to the u, and I wouldn't be able to do integration by parts because there'd be bits left over.
Okay.
Now, a different world. If it had been that guy, let me change this to 3. If it had been that guy, what technique would I have used?
Couldn't you still use substitution, but instead of it just being u, you do it the square root of u?
Well, you could have. This one here, my question is, what would you choose? In this question here, you just do u equals 3x cubed or x cubed. And this one would just be a u sub. Now, if you try and do an integration by parts and you have a u to the 1/2 e to the 2u, for example, oops, to you, I'm saying to you, that one doesn't go anywhere. If you try integration by parts on it, you're always going to have an integral left over that's just as ugly as the one you started with. And there's no way of fixing that.
Okay.
It's just ugly. But then, since it's impossible, you wouldn't be given the question in the first place. So you can only be given integrals that are doable. If it was impossible, they would get round it by just saying, what's the answer to 2 decimal places? In which case you wouldn't need to do any of this. You'd basically just integrate that from, I don't know, 0 to 1 or something.
Okay.
Okay, we are about finished for today. I'm going to hang about because sometimes people have questions they just want to ask on their own. Hopefully I've told you enough. This video will eventually this evening be online, probably this evening at least, maybe tomorrow morning. So if there's something that you've forgotten, you can watch the video again. Okay, so last name and bye-bye, and I will see some of you on Monday. Hopefully I'll see a lot of you on Monday, and we can go over some topics that you want some help with.
Professor,
Yes.
could you solve the question for me, which is question 10 in the homework, chapter 9.3?
Sure. What is question 10?
It's du over dt equals 2t plus secant square t over 2u, and then initial condition is u0 is equal to -1.
Did you say -1?
Yes.
Okay. So this guy is already ready to go. It's all, you know, ready to have variable separable done to it. So that guy and that guy, you comfortable about the crossover?
Yeah.
Okay. This fella is u squared. This guy is t squared, and that guy is tan t.
Right.
And this guy gets the plus c. And then you would take the square root of both sides to isolate the u. And when you take the square root of both sides, there is a choice. It's either plus or minus. Normally I choose plus because I'm assuming that's what's happened. But can you see in this case, the answer is -1. So what that's telling me is that it's the negative square root I'm going to be using, not the positive one. So when t equals 0, u equals -1. So I can put -1 here. And I make t 0. And what that will eventually do is allow me to get c. So I have -1 is the square root of c. I think it's pretty obvious that c will be 1. The negative square root of 1 is -1. So my particular solution is negative the square root of t squared plus tan t plus 1. Was it this missing negative that was causing you the problem, Koichi?
Yeah, it was. It was actually it was.
Okay, no,
Yeah.
that's
Yep.
it.
Yep. Thank you so much.
Not a problem. Any other question, guys, before we go?
I was wondering, why do you put the negative in?
Here,
How can you tell?
from up here, the boundary condition says that the value of the function u when t is 0 was -1. Now, when I was over here, I could have said plus square root or negative square root, but u can only be a negative number, in this case, -1. And so because u has to be negative, the only way I can make it negative is by choosing the negative square root guy.
Oh, okay.
Right. Very often, when you take a u squared and you make it a u, you take the positive square root. Because just by whatever, by life, most of the time it is positive, right? But if you've got a boundary condition, that could change. For instance, see if this said u of 0 was 10, I would be using a positive square root. If it said u of 0 is -10, I would have been using the negative square root. So that's how you tell, right? It doesn't matter if it's u cubed, because when you take the cube root of something, you don't have a plus minus decision, right? Cube roots are plus or minus depending on what's inside the cube root. So you only need to worry about that for even powers, right? U squared or a u4, for instance. More likely the u squared.
That makes sense.
So if
Mhm.
if there's no given boundary, would we just leave it as a plus or minus value?
If you're being lawyer-esque, you should put in both. But if you only put in the plus, I would give you the points, because to me, that's the assumption I would make, that it's positive. So make the assumption it's positive unless there's other information to tell you otherwise. I don't think WebAssign even allows plus and minus as a choice. I think you have to go one or the other. So if there's no boundary condition to help you decide, I think your safest bet is pick a positive. Any other questions?
Nope, I just hope you have a good, healthy weekend.
Well, thank you. Do you want to send me a bottle of whiskey to help with that?
Nope,
Okay, well, it was worth asking.
bye.
Okay, bye-bye. I will see you on Monday, probably.